Okay, hi guys. Again, this is the last part for 1C. I'll do question 7. Over here, you have a parabola that has a y-intercept, and it also passes through 2 points, 2 and -1, -1 and 10, and they want you to find an equation for this parabola in standard form. So they're already giving us some guiding factors for that. So we'll use it in standard form. I'm going to actually plot these points so we can kind of see where the parabola would look like. And then algebraically, we'll go from there. So our 2 points, this is just the graph from 1C. For number 6, you can see that the 2 of them are different. So we'll just remove these. So a y-intercept of 4. So I know that the coordinates would have to be 0, 4. They'll ask me if I can label this points, and I will. So let's zoom in a little bit. Okay, good. So there it is. I can see that I have a point. It says it's at 2 and -1. So we'll plot this point here. So we can write that this is the y-intercept if we want to give a label to it. This is point 1. We can call this point A if we want. And then let's look at the next point that they want us to input. It's going to be -1 and 10. It's always good to have a sketch to see what you're working with. It's not necessary, but I love visuals. That's why we're having a graph. Okay. So here are my 3 points of where my parabola is supposed to pass through. So whatever parabola that I'm going to type in, it should be passing through those points. This one needs a label, so let's label this one point B. I. Let's try that again. -1 and 10. Give it a label. It's purple now. B. Okay. So let's go to our board and discuss strategies. So this is a thinking type question. They're giving us a little bit of a hint because they want it in standard form. I'll go over the forms, the 3 forms that we looked at briefly again, and see what would be appropriate to substitute those in. So the first forms that we were looking at originally was factored form. So factored form, you have the general form of y is equal to a, x minus r, and x minus s. And again, this is only good if I actually had x-intercepts. So if I had x-intercepts, I would for sure try to use this, but they give me instead the y-intercept and 2 points. I know these are not the x-intercepts because we would have y is equal to 0. So we're not going to use this one. The other one was vertex form. Again, the general form is y is equal to a, x minus h squared plus k. And again, we would be given the vertex. They don't specify that any of these points are the vertex, so this is not the best one to use. So the one that we would use is standard form. So let's try to substitute our information here in standard form and then see what we're going to get. So in standard form, our general is y is equal to ax squared plus bx plus c. And I'm going to actually use this one because it gives me information of the y-intercept, which would go here appropriately for c. And then here you have these points. Remember, points are just x and y values that correspond with each other. So this was our a, I believe. So this is x, y. This is our b. This is also an x, and this is a y. So you would have to substitute each one of these points into one form of an expression in standard form with the y-intercept. And we're actually going to end up with 2 expressions and see how we're going to solve it from there. So let's do the first substitution. So I'm going to sub. So this is going to be equation 1. We're going to sub the y-intercept of 0 and 4. I guess we can just write it like this. C is equal to 4 because I know this is the y-intercept. And I'm also going to do one of the points. So we can pick A, 2, and -1. So anytime that I see x, I'll put in the value of 2. Anytime that I see y, I'm going to put in the value of -1. So here, y is going to match this y. So I'll write -1 first. I have no substitution for a right now, so I'll leave it the same. The x value is going to be 2. So this is going to be 2 squared. I have no value for b, so we'll leave it unknown. And again, the same corresponding value will be the x, so it'll be 2 here. And then this c I know is going to be equal to 4. It's positive, so we're going to add plus 4. So now we're just going to simplify this line using BEDMAS. So -1 is equal to 2 times 2 is 4, so this will be 4a. This will be 2b. And this plus 4 doesn't have anything to simplify here with on the right side. So I'm actually going to carry it over and collect like terms. So if this is being added, I'm going to now subtract 4 on both sides. So let's move this 4 over. And then my simplified expression would have the 4a and the 2b on the right side of the equal sign. And this one would simplify that if I owe you $1, I owe you another $4. So now I owe you $5. So here's one of our expressions that we're going to need to help us solve for the values of a and b. Okay, so we're going to do it again. We're going to substitute equation 2 with the same c value, but instead of using a, we're now going to use point b. So let's do it on another board. So let's do this one in a different color. So I have equation 2. I'm going to sub. The c value is still the same, and I'm going to substitute point b in for x and y values that I see. So -1 and 10. So this is x and this is y. So let's substitute it into this general equation in standard form. The y value here is going to be 10. So I'm going to write 10 here to begin with. Again, I don't know what the a value is, but the corresponding x value is going to be -1 squared. This one for b, I still don't know what it is, and this is going to be -1. And the c value, we'll substitute that for, and again, we're going to use BEDMAS to simplify. So I know for sure this 4 is going to get moved over here. So again, if it's being added, I'm going to subtract it to both sides. So I know already this is going to be 6. This is -1 squared, which would make this whole term positive. So this is just 1a. I guess you don't need to write the 1. This one would be -b. So this one is our second equation that we would have to simplify. So when we look at our expressions, we have two expressions that we were able to simplify. -5 is equal to 4a plus 2b. And then our other one is 6 is equal to 1a minus b. So this is a grade 10 concept using a system of linear equations to solve for two variables. You have two equations, one's purple, one's green. You have two unknowns, which is a and b. So that's perfect. We can solve that using some algebra. So we're going to either add or subtract the equations. It's set up for elimination, so I'll use it. You can easily use substitution as well. Most kids like substitution. Maybe I will do substitution, but if you prefer elimination, it's already set up that you can do that. You would just have to double the green equation. So let me write the purple one on this same sheet here. So we can see them side by side. Negative 5 is equal to 4a plus 2b. Negative 5 is equal to 4a plus 2b. So if I wanted to use substitution, that means that I would have to isolate one of these variables for a and b. In this expression, it's easiest to do it for the one in green. The only coefficients that are in front of this is 1. This one I would have to do an additional division to isolate for the a or the b, either the 2 or the 4. So I'll stick with this one. So I'm actually going to isolate here for a because it's already there on the right side. I'm just going to move that value over for b to isolate for it. So this one would be adding b to get rid of this. This one would just result into 0, so I would have 6 plus b is equal to 1a. And then I would take this expression, and anywhere that I saw a, so I can write it like this, I'm going to substitute that in here, in the second expression. So we're isolating in 1, and we're going to substitute it in here. So anywhere that I see a, I'm going to input this expression instead. 6 plus b. So in purple, everything stays the same. Negative 5 is equal to 4. So I have to actually multiply everything that I had for a by 4 because that's what it's asking me to do. And this one would be here. So the intention of this is that instead of having 2 unknowns, I now have just one unknown, just these b's. So let's simplify this. This is negative 5 is equal to, I'm quadrupling every term in here, so 4 times 6 is going to be 24. 4 times b is going to be plus 4b. This is 2b. And then let's simplify this. I'm going to get 6b here. And this one over here, this is 24. I want to collect it with the like terms. These are the like terms that were on the right, but these are constants. So let's subtract 24 here on both sides. And then we're going to get negative 24 minus 5, which is going to be minus 29. And then we're going to divide both of these by 6. And then our b value is now going to be negative 29 over 6. So yes, there's some algebra that's involved. It's a thinking type question. We're not actually done yet because we only found the b value. We had 2 unknowns, so now we're going to solve for a. And how do we solve for a? If I know that this is equal to b, I have it already isolated here conveniently for us for a. So let's substitute that in there. So a is going to be equal to 6, and they're adding this, so I can add negative 29 over 6. Here we would need a common denominator because we're adding or subtracting fractions in this case. So let's give this a denominator that's common. We would make this 6 over 6. So our a value would be now 36 over 6. This is equivalent to just 6. I'm going to subtract 29 over 6. And if we see how many values for this, this should be 7 over 6 for a. So now that we have our values of a and b, and then the c value was given to us, we're going to now write therefore the equation in standard form would be y is equal to a x squared, our b minus 29 over 6x, and then plus our c value of 4. So of course, like always, we're going to check on Desmos to make sure that if we input all of these values, it actually goes through those points that we originally labeled on the graph. And if it's not, we made an algebraic mistake, which is fine. We could always try again. So let me get our Desmos graph here. So again, these are the points that we labeled. Here they are on our graph. Let's type in our newfound equation. This is 7 over 6 x squared minus 29 over 6, that over x, and just switch hands, and then plus 4. And here we have our graph that you can see that opens up in this case because we have a positive a value, so that's good. And it actually goes through these points that we looked at. Here, here, and up there. Okay, great.